Next, we have exercise 4 to talk about on our rate of change handout. It's down here at the bottom, and I copied exercise 4 onto a separate sheet, so it's a little bit easier to write and talk about. And so in exercise 4, we're going back to a function, a linear function, f of x equals 0.15x plus 3.25, that we used in an earlier application when we were working with linear functions. The x input variable is hours after midnight, and f of x is the depth of a river in meters. I think the river level was rising with time due to flooding. And so what I want to do is go back and relate this idea of average rate of change to that function. So let's just go ahead and calculate the average rate of change of this function on the interval 0 to 4. So we're just going to apply our formula for average rate of change. We're going to take f of 4 minus f of 0 over 4 minus 0. Now, f of 0, I can pretty much see in my head. F of 4, maybe I'll figure this out over here on this side. When I plug in, I get 0.15 times 4 plus 3.25. And so 4 times 0.15. Okay, it's okay to use a calculator to help you too. This turns out to be 3.85. And f of 0, I don't even have to write out because I can just see f of 0 is going to be that 3.25 value, the y-intercept of the line. So let's go back to this calculation. F of 4 minus f of 0. I'm going to lower this down a little bit. F of 4 is 3.85. Minus f of 0 is 3.25 over 4 minus 0. I get 0.6 over 4, or 0.15. Bring this over here. And now, because this is an application, our average rate of change is going to have units attached to it. In our division, we were dividing function values that were meters by input values that were hours. So since we divided meters by hours to get the 0.15, our units are meters per hour, and those units are part of the average rate of change. It looks like the slope of the linear function. And in fact, it is the slope. It will always come out to be the slope. In fact, what I'd like to do now in part B is take that same function and find the average rate of change of f on any interval. So we're not going to use actual numbers. We're just going to work with a and b. F of a would be equal to 0.15a plus 3.25. That's all we can say because we don't have a number for a. F of b is going to be 0.15b plus 3.25. And so the average rate of change of f on the interval from AB. So we're still in exercise 4, so we're using our function that was given for exercise 4 here. This is f of b minus f of a over b minus a. That's the formula for average rate of change. If I plug in, I have 0.15b plus 3.25 minus 0.15a plus 3.25. Now here's a good little algebra point. I'm subtracting that entire function value. I need to put parentheses around that the two terms that I'm subtracting because they're both going to be affected by the minus sign. That parentheses is crucial. You need to know that that minus sign is going to have to be distributed through the two terms at the end. So I have 0.15b plus 3.25 minus 0.15a. When I distribute, I get minus 3.25 because I'm distributing the minus sign to each of those two terms over b minus a. And the minus sign helps because I have 3.25 minus 3.25. That goes away. Now I have 0.15b minus 0.15a over b minus a. Seems like kind of a mess, but something nice is about to happen to us right here. Up above, I can factor out a common factor of 0.15 times b minus a in parentheses over b minus a. And the b minus a is going to cancel. I have 0.15 over 1, or 0.15. And just notice that I got that value 0.15 doesn't have anything to do with A and B at all. Now it's meters per hour again, because this is still from our application. But the important thing to see here is that we got the slope of that linear function working from this more abstract formula, B and A. For any linear function, average rate of change always comes out to be slope. So in a certain sense, with linear functions, average rate of change is kind of boring. When functions are not linear, like that Cynthia driving example, our example number 1, you get all sorts of different average rates of change over different intervals. So that's exercise 4. I think we got just a little bit more for our next video.